Hello guys. Hello, welcome back everyone. So we are back again with a new live session on Python generators. Okay. So today we are going to see the Python generators, that what are generators in Python, how we can create them, how we can use them, what are the use cases where we can apply the generators. Okay. Now let's do what? Uh, let's first solve some, we'll follow the same structure guys. Just like we follow in our every live session. We'll start with the quiz session and then we'll continue with our topic and then we'll solve some problem based on our topic. Okay. So yeah. Now let's do what? Uh let's first solve some basic yes and no questions. Okay. Let's give answers of basic Python questions so that let people more people join and then we'll start with Python generators. Okay. Okay, guys. So your question is Python an interpreted language? Yes or no? Okay. So yes. Lakshmi Creation is saying hi, hello. Okay, Python generator. No, Python generator does not provide video recorder. Lakshmi Creation, can you more clear means what type what you are asking means I'm not clear. You asking about the generator or in general you are asking about that we provide video recordings or not? So please clear it. Okay, so I can see two yes for that is Python an interpreted language. So yes, Python is an interpreted language. So yes is the correct answer. So those who have given yes, that is correct. Okay, now I'll do what? I'll alongside the question I'll write the answers also so that it will be easy for everyone to know. Okay, guys, your next question is can Python run on multiple platforms like Windows, Mac, and Linux? Yes or no? Okay, Saurav Gamer is saying yes. Okay, let's see if anyone who knows. Okay, there is one more yes. So I'll go with yes now because so yes, Python can run on multiple platforms. It can run on Windows also, Mac also, Linux also, and some other operating systems also. Okay, because it is platform independent. So yeah. Now guys, these are very basic questions of Python. Okay. So I hope those who are friendly with Python, they will definitely know the answer. Okay. Now, guys, your next question is indentation optional in Python? Okay. I hope you guys know about indentation. Okay. If anyone who does not know about indentation, they can just let me know in the chat. And if everyone knows about it, and those who are programming in Python or those who use Python, they will obviously know about indentation. Okay. So is indentation optional in Python? Yes or no? Okay. Saurabh Gamer is saying no. Okay. It means it's not optional. Okay. Anyone who knows the answer? Okay, so I'll go with no. So yes, Saurav Gamer, you are correct. No is the correct answer. Okay, that indentation is not optional; it's mandatory. Whenever you have to, suppose you are creating a function or a loop. Okay, so whenever you have to define a block of code, so you have to use indentation in that. So it is mandatory. So it's not optional. So no is the correct answer. Okay. Yes, life hack reels. Yes, no is the correct one. No is the correct option. Yeah. Okay. Guys, your next question is, which is question number 4. Does Python support object-oriented programming? Ooh, yes or no? Okay, Saurabh Gamer is saying yes. Okay, let's wait for few more answers and then we'll I'll tell you the answer. Okay, live hack reels is also saying yes. So okay, so I'll go with yes. Yes is the correct answer. Obviously, Python supports both object-oriented programming also and procedural approach also, means modular approach also. So yeah, yes is the correct answer. Okay, guys, your next question is question number 5. That is, can we use both single quotes and double quotes for strings in Python? Yes or no? Okay. Saurav Gamer is saying yes. Okay, for 5 it's yes. That we can use both single quote and double quotes. Okay, let's wait for other. Okay, live hack reels is also saying yes. Okay, so I'll go with yes. So yeah, yes is the correct answer. That we can use both single as well as double quotes. So yes is the correct answer. Now let's move to the next question. That is question number 6. Now some data structures questions. Okay, is tuple a mutable data type in Python? Okay, tuple or tuple, whatever you say. It is a mutable data type in Python or not? Yes or no? Okay, Cutie Cat is saying yes. Okay, Saurabh Gamer is saying no. Okay, let's wait, or we'll go ahead with the correct answer, whatever it will be. Okay, so I'll go ahead. I'll tell you the answer. For question number 6, the answer is no. Tuple is not mutable in nature. It is immutable in nature. Okay, so those who have said no, it is correct. Okay, yeah, no is the correct answer. Okay, let's move to the next question. That is question number 7. It is based on Python functions. Can Python functions return multiple values? Yes or no? Uh, Cutie Cat is saying tuple is immutable. Yes, tuple is immutable in nature. You are correct. Now, The next question is question number 7, that is, can Python functions return multiple values? Yes or no? Okay, Saurabh Gamer is saying yes. Okay. Anyone who want to give the answer of this question? Okay, Live Hack Reels is also saying yes. Okay. So let's do what? Let's go ahead with yes. So those who have said yes, it is correct. Python function can return multiple values using conditional statement or using other phenomenon. Okay. So yeah, the answer is yes. So yes. Okay. Guys, your next question is, now let's see who knows the answer of this question. Okay. Is question number 8, is pass a keyword in Python? Okay. Is pass a keyword in Python? Yes or no? Okay, Minrugan is saying yes. Okay. Now, guys, give me the answer of this question. Question number 8. Is pass a keyword in Python? Yes or no? Okay. No. Live Hack Reels is saying no. Saurav Gamer is saying yes for empty functions. Okay. Cutie Cat is saying Python is a dynamic programming language. Correct, sir? Yes. Yes, you're correct. It is a dynamic programming language. It has dynamic variables in it. Okay. Okay, yes. So I can see two yes and one no in the chat. So guys, those who have said yes, it is correct. Okay. That pass is a valid keyword in Python, which is used to create empty functions or empty block of codes. You can create a empty class also using pass. So yeah, it is a keyword in Python. So those who have said yes, it is correct. Okay, guys, your next question is question number 9. Does Python have built-in support for multi-threading? Yes or no? Now, what do you mean by built-in support for multi-threading? It could means that do you have a library which is built in nature, means you have to directly import it, no need to install it, like such things are already present with the Python, built-in Python? Yes or no? It means that. Okay. Support means that. So yeah. Okay. Live Hack Reels is saying yes. Okay. Saurav Gamer is also saying yes, not sure. Okay. But it is yes. Okay. So I'll go with yes now. So those who have said yes, okay, it is correct. Yes, Python have a built-in support for multi-threading. So, okay, Qt Cat is also saying yes. Yes, it is correct. Okay, guys, your next question is, which is question number 10. Can we overload methods in the Python same way as we do it in Java and C++? Okay. So question number 10, can we overload methods in Python the same way as in Java or C++? Okay, Saurabh Gamer is saying no for 10. Okay, no. Okay, Live Act Reels is also saying no. Okay, so I'll go ahead with no. Okay, guys, I'll go ahead with no. So those who have said no, it is correct. We cannot overload methods in Python as the same way we do it in Java and C++. Somehow we can overload a method, but with using variable length arguments. Okay, so not like in Java and C++. Okay, QTGet, you are also correct. No is the correct answer. Okay, now guys, this was the basic quiz questions. Okay, we have seen it. Now, what I'm planning, I'm thinking that I should give you a brief introduction of Python generators. Okay, so let me just give you a brief intro on Python generators, because see, there will be some people who are friendly with generators, who are friendly with Python, so they will know it, okay, obviously. But those who don't know about Python generators, for them, I'm thinking that let's see generators in a brief and then continue with Python generators quiz session, okay, and then we'll solve the problem. Or then if anyone will have problem, so then we can discuss generators in more detail, and then we can continue with our problem section. Okay, so I'm thinking that. Okay, so let's just do what, let me bring this cell down. Okay, so guys, Python generator, what are generators in Python? First of all, the first questions when we'll think of Python generators will be that what are generators in Python? Okay, so what are generators? See, a generator is, you can say it is a special type of iterator in Python. Okay. Now, what do you mean by iterator? Iterator is like how you iterate over a list using a for loop. So it is also like a iterator only. Okay. So a generator is also a special type of iterator in Python that allows us to generate values one at a time. Now this, the mark this line, okay? I'll just do what? I'll just write this points, okay? Because these are some of the points which are very much important. That is that it generates values one at a time, okay? Now, so let's again repeat the definition. A generator is a special type of iterator in Python that allows you to generate values one at a time using the yield keyword. Okay, yes, there is a keyword called as yield. So using this yield keyword, okay, we can generate one value at a time instead of returning all values at once. Okay, so normally when we use return, so it just returns all the values, okay? But what if you want to return one value at a time? So then you can use yield. Now we'll see it in more detail. First, let me just write all the points. So yield, it uses a keyword called as yield, okay, to return values one at a time, okay? Now these are the two things which you have to take in consideration when you talk about Python generators. Now, it will be more clear when I'll give you a difference between a normal Python function, a normal function, and a generator. Because a generator also looks like a normal function only. So what's the difference between a generator and a function, let's see that. Okay, so it will be more clear. So let's talk about first of all a normal function. So I'll do what? I'll first of all create a function for you guys, a normal function that will do what? That will do nothing. It will just simply return some value. Okay, so normal function, and this function is going to return 1, 2, 3, a list. Okay, and then what I'm going to do, I'll just use the print function and I'll print the normal func. So I'll get 1, 2, 3. Okay, that's obvious. What we are returning, we are getting it. Okay, so this is a normal function. Now what it does, it is executing and it returns value. Okay, then the function will terminate, because when we use return inside a function, so this return will be what? This is the last line which is executed in that function. So whenever you return anything in your function, so after this, if you put any line, suppose if you're printing a print over here, suppose print hello, so what do you think? No, this will be uh, useless code, because it's not going to be taken in consideration, because this return, whenever you use return, the function terminates, okay, there only. So there is one thing which you can write about normal functions, that it terminates after returning. So terminates after returning. And one more thing which you can write about normal function is that it and executes and returns value once. Okay, so it will return a value only once. As you can see, I have returned 1 to 3, so it has directly given 1 to 3. Okay, then one more thing about the normal functions are, that is, it stores all result in memory. If it has no return, okay, if it has to return multiple values, so it is going to store all the results in memory. So memory consumption is more for normal functions. So what we can write here, we can simply write results in stores all results in memory when if it is has to return multiple values. Now we'll see each and everything. How much size does this normal function take? How much size does the generator function take? Everything we'll see. Okay. So yeah. Now this is a normal function, and these are some of the things about normal functions. Now let's talk about a generator function, how it works. Okay. So the difference will be clearly visible. Okay. So now let's do what? Let's talk about the generator functions. First of all, before talking about the generator function, I'll just create a generator function for you guys, and then we'll talk about all of the things. Okay. So let's say we have def, and we'll create a generator func. Now, anyone having any problem in any of the topic, just let me know in the chat. You can write whatever your question is. Okay, I'll check it and I'll reply that. Okay, on your question. So, guys, generator func. Now, as I have told you about generator, that it uses the yield keyword to return values. Okay, so now, just like a normal function, we are not going to use return here. We are going to use yield. Okay, now how this yield works, that we'll see. But for now, just know that we are going to use yield in a generator, not return. Now how this yield works, that we'll discuss more in detail. But for now, this. And if you want to print, if you want the output, so you have to do like this. You have to store the generator func call in some variable. Okay, and when if you want to print some value, so if you'll print gen, now when you'll print gen directly, so you will get the object, okay, and the memory address like this. You'll not get your value. If you want your value, means 1, 2, and 3 like this, then there is one function that you have to use, and that function is next. So what you have to do, it's very simple. You will need to put this gen, the variable in which you have stored the function call, that you have to put it inside next. Okay, and then it will be like this one. Yeah. So when you will use this next, what happens? It basically gives you this eld. Now, if you want to print two, okay, before explaining it, I'll just want to show you everything. Now, if you want to print this two, so then what you have to do, then again you have to print the next gen. Okay, you have to use the next gen again. Now you'll get two. Now again, if you want the three, so you'll do what? You'll do like this. So you'll get three. Now, if you again want to do it, then nothing will happen, and it will give you a stop iteration exception, that there is now you are yielding only three things: one, two, and three. And if we have called next fourth time, so then you will get this exception. Okay, that is a stop iteration. It basically means you have yelled three things, so why you are calling next four times? It basically means that. So we'll remove this and we'll simply call it. So now you will get 1, 2, 3. Now let's talk about generator. Okay, in more detail. What is the difference? Let's talk about that. So first difference, now with the code you will, or everyone will know, the first difference is the yield. So we used yield instead of what? Instead of return. So instead of return means instead of return we just use yield here. Okay, that is the first difference between a normal function and a generator function. Okay, then what happens when we are talking about a normal function? So normal function does all the things at one go. Okay, but while in a generator function, pause and resume execution happens. So it uses pause and resume execution. Okay, now how this, where this pause and resume execution applies, that I'll explain you. But for now, okay, this is the thing. Then it generates values one by one. Yeah, that we have seen, that it generates values one by one. That we have seen already, which is also known as lazy evaluation. Okay, which is also known as lazy evaluation. Okay, then the next thing is it saves memory. How it saves memory? uh, it does not store the whole sequence in memory at once. Okay, one by one it does. It generates values on the fly, on the go. Okay, it does not store on memory and from memory it fetches it. No, it's not like that. It just generates the values on the go, on the fly. Okay, so that is the thing where it saves the memory. So let's write that also, that it doesn't store the whole sequence in memory. Okay, these were the things which makes generator functions different from a normal function. Okay, now let's talk about the whole execution of this part. Okay, guys, see what is happening here. Let's talk about that. What happens internally when we create a generator function, when we use yield, and then when we use next to call or to just generate the values, what happens internally? Let's talk about that. See, so when Python sees yield in a function, okay, when Python sees yield in a function, so it treats it like a generator. Okay, so when there is a function, and inside the function we have used yield in it. So Python will treat it as a generator. Okay, so now this function, generator func, when yield was, means when I wrote yield inside it, so now the Python will treat it as a generator. Okay, now calling the generator calling the generator function does not execute it immediately. Okay, so what it does, it returns a generator object that we have seen already. So when I'll print simply gen, okay, so it will give us the generator object. Okay, it is not going to execute it immediately, just like in return. Just like in the normal function, what happens when we return a list and we just print the normal function, or we call the normal function, so we got the value directly immediately, but that will not happen in the generator function. So when the value will be generated, so execution starts only when you call the next, okay, the next function. Or what you can do, if you don't want to use the next function 3 times, 4 times, or whatever times it is, so you can just start a loop. Okay, you can use a loop also. Inside the loop you can put this next gen, you can use a for loop, and then also you can do your thing. So you can do that also. So that is the thing. So execution will only start when you call the next function. Okay, so this is what happens internally. Okay, I hope everyone have understood about this much about Python generators. Okay, anyone having any confusion, any problem, just let me know in the chat, or else what we are going to do, we'll start the quiz session of Python generators. Okay. Okay. Saurav Gamer is saying, can you give one example in relation to the real world? Okay. Yeah. So what you can do, okay, yes. You can think of I hope everyone knows water tank and water dispenser. Okay. So I'm going to take that example to to just to relate you guys to generators and a normal function or a normal list. Okay, so yeah, okay, guys, think of uh a water tank. Okay, now imagine you buy a huge water tank. Okay, so what you do, obviously you have if you have buy a huge water tank, so you will store all the water first. Okay, and then you will take water from it. Okay, so that's what, that's like creating a list of 1 2 3 4 5 3 or whatever elements you want. So you have created a list and you have stored all the elements in the list in the memory. Okay, so that is what, that is like a water tank. then then there is one thing called as generator. Now, if you have heard of water dispenser, what is the work of water dispenser? It dispensers, a dispenser is what? It just gives you, suppose if you want a glass of water, so what you will do? Dispenser will give you that much, means only that much amount of water for you. Okay. So a dispenser will give you a glass of water when you ask for it. Okay. Or when you'll just follow some step, or uh, when you'll press the button, then it will give you that much amount of water only. So you have a water tank already with you in which you have stored all the water. Now the generator will do what? It will act as a water dispenser that will give you how much you have asked for it. Okay. So it does not store the whole tank in memory. It just supplies on demand. Okay. So a generator is like a dispenser that gives you data one at a time, only when you need it. Now, how we can relate this example? We can relate this example like this. Okay, we have the function with us. Okay, that function is yielding three things. Okay, but what if I want for now, I want only one? So in the first case, I just wanted one. So when I wanted one, so I'll just call the next gen only one time. Then, then I feel that now I have the need of this two also. Then what I'll do? I'll again call the next gen. So it will call two. Okay, then if I'll feel the need of three, so I'll do that also. Okay, so I'll call again that. If you want one more example, so there is one more beautiful example, which is of food delivery versus the buffet system. Now how it is, think of like the buffet. Okay, in a buffet, what happens? All the food is cooked and displayed at once. So whether you eat it or not, the food is already there. So this makes what? This wastes the space. Space means this wastes the food. If everyone eats it, then fine. If not, then the food is already cooked. No, so it is going to be wasted. So this is the buffet. That is a list. You have created the memory. The memory has been already used. So whether you used it or not used it, memory has been used. Okay. Then, then there is this generator, the food delivery applications or the food delivery restaurant. So there are some restaurants who delivers food also. Okay. So in food delivery system, what happens? Your meal is cooked only after you place the order. Okay. So you will first place the order and then only based on your order the cooking will start and then it will cook your meal. Okay, so first you have to place the order. So it does what? It saves the resource. Am I right? It saves the resource and is just ready in time. So most important thing is there is no waste. Okay, because when I'll feel hungry, I'll order it. The food delivery person guy or the hotel or the restaurant will make the food for me. They will deliver it to me. I'll pay them and then I'll just eat it. Okay, so generators are like the food delivery applications or food delivery services. Okay, they serve on time. They serve items only when you request them. Just like the generator. When you want it, you call it. When you need it, you call it, and it will be done. Okay. Okay, Dhruv Verma, namaste, namaste. Okay. So yeah, that is the thing. Now I hope it is clear. Okay. Now one more thing, guys, which is very much important. This combination of yield and next. Okay, how they work together. Let's talk about that. See, uh, when we use yield, what happens? I'll just give you a comment here so that it will be more easy. Okay, this line when I have told you that it use pause and resume execution, how it uses the pause and resume execution, let's see that. When you use yield, it does what? It will pause here and it will pause here and it will give a value. So when we use yield 1, so what will happen? The execution will be paused here and then it will give a value. So what value it will give? It will give 1. Okay. Then when we'll use next, when you'll use next, then it will continue the execution from where you left off. And one more thing, and it give me the it give me the next value. Okay. That is how the pause and resume works. So the yield, when you use the yield, it pauses there and it returns, it gives a value. When you use next, and continue from there where you left off and give the next value. Okay, that is how the pause and resume works. To show you in more detail, I have one more example that will be more meaningful. Let me make a function called as demo. I'll make it a generator function. So I'll do what? I'll just write I'll use some of the print functions. Okay, I'll yield 10 in it. Okay, then I'll print, let's say I'll print a step 2. I'll yield 20. Then I'll just copy it and paste it over here, and I'll change step 2 to step 3, and I'll make it 30. Okay, so this is a generator which we have defined. Now let's uh, create the generator object. So for creating a generator object, we just need to do this. Okay, now your generator object has been created. Now we have to call for the first time. Okay, so what we will do, we'll call for the first time. So let's call it print next g. So when I call for the first time, what we got, uh, execution started. Okay, execution started from the top of demo, means from here the execution got started. It prints step 1. Okay, that we can see in the output. It printed step 1. Okay, then it hits, first line is executed, and in the second line it hits this yield. Okay, when it hits this yield, so it will pause here. It will take a pause. It will pause here, and it is going to return, and it will return 10. Okay, so it returns 10. Now generator is now frozen at this point. At this point the generator is now frozen, but one more thing, it is frozen but it is remembering its place. It means that it remembers that till second line the execution is completed. Okay, now let's call one more time. Let's make the call, or why need to write, just okay. Okay, one second, I'll just need to call it here. Step 2. Okay, now when I did the step 2, what happens? Execution resumes right after the first yield. So first yield I have called it over here, so it just resumes from there, means from the second line it's come to directly to the third line, step 2 and then 20. Then if I'll again call it, it will come here and it will give me step 3, that is 30. So it works like that. Now one more, if you'll call it one more time, so then you will then the generator will resume, but it will find that there is no more code to run because we have used only 3 yells. Okay, so then it will raise and stop iteration, which means that now Python knows the generator is done. So now there is nothing to display. So that is the internal process, what happens, or the combination of yield and next, how they work. Okay. Okay, there is one question from Subham. Hello, Subham. That sir, in real projects, when do we use or have to use? Can you please give examples? See, whenever one simple example is uh, for your question is, whenever we have to do API calls. Okay, whenever we are using some other application for integration, suppose you are programming in Python and you are creating one smart student manager. Okay, like agentic AI, if you have to create, suppose I'm just giving you example. So at that place, you will need some OpenAI APIs or some AI API for some feature like when you have to syllabus analyzer based on your syllabus, that particular application will do what? It will give you how you have to what topic you have to read at what time, and it will just create the whole schedule for you. Okay, so for that purpose, you'll need a OpenAI. Okay, OpenAI API. So to make calls to that API, you can use it. You can use this phenomenon. Okay, you can use generators that when you need it, then only you return the value. Okay, so then you can use this. Or whenever you are performing some data analysis, okay, like suppose you deal with large data, like there is some file, or there is some database record, okay, or there are some logs. So what happens, they are very huge files, so you cannot load it at once. The whole file you cannot load it at once. Okay, if you load it also, so normal system does not support that. You need a high valued system, okay, with high level of gigahertz and all, okay, with high processors. So for that types, what you can do, uh, you just need to load into your memory at once, and then you can use the generator thing, and at one go it will give you a part by part details of that files or of that database. Okay, or suppose when you have to perform a lazy evaluation, there are some cases where you want to evaluate your process lazily, means very slowly. Okay, means suppose when you want your process to generate values on demand. Okay, when you demand it, only that time you will need it. Other than that, you don't want that your function should compute and store everything at once. When you demand it, it will execute that much amount of, and then it will stop there, and then again when you will demand it, it will again execute for you. So at those places you can use it. Okay, again, okay, got it. Okay, you understood, that's good. And does it save in RAM or HDD? No, not in RAM, not in HDD, not in SSD. See, generator do not store all values anywhere. Okay, not in RAM, not in HDD, or at no local storage. Okay, is involved. It produces one value at a time on the fly. Okay, what do you mean by on the fly? It means lazy evaluation. It does the evaluation only when you ask for it. Okay, so it does not store anything anywhere. It just generate values on the fly. That is the thing. It stores only one thing. Yeah, one more thing is, guys, you must know about uh, this generator thing. That is, it does not stores the values. Okay, but it what it stores the the function execution state. Okay, what do you mean by this? It means where it paused last. Okay, that thing it stores. Suppose for this example, I have yelled three things. Okay, yell 10, yell 20, yell 30. So now for the first yell, for the first next, it just printed that. So it just paused here. Okay, it's just make a pause here. So now what it remembers this state, that at what place it has stopped. So at this place. So it remembers that this yell is executed. Now whenever we will again execute this function demo, so it will start execution from here. Okay, so it remembers this thing, the execution state of the function. Okay, then it remembers, it stores the local variables at the moment, at that moment. whatever, if I have created a local variable inside the function, it will remember that. And one more thing which it stores is the current yielded, which the current yield value. Suppose for the first next it is 10, so it is going to store that. And where does these three things which I have mentioned, the function execution state and the local variable at that moment and the current yielded value, where these three values are stored is RAM. Okay, it is stored in RAM. So these informations are kept in RAM, uh, but it is see, it is very less in size. Less in size means it extremely small, just enough to know where to resume when you call the next again. Okay, it's very extremely small. Okay, extremely small in size. So yeah. Yes. So again, guys, one more nice question by Subham. Subham is saying, okay, perfect. So it is a good idea to use yield when we have a low CPU. Okay. So now the answer for this is means you can see, Subham, uh, when you have a low CPU, so not really that means somehow it will work, means somehow it is a good thing, but not really. Why? Because see, yield is about memory efficiency, not the CPU speed. Okay, it is about the memory efficiency. It is about the RAM, not about the CPU speed. So a generator will still need the CPU to compute each value. Okay, if you have multiple yield, so the computation will happen. It's not like that the computation will not happen. It will be happen, but it just does not store uh, all the values in memory at once. That is the thing. One by one, it will do that. If your RAM is low, means if your RAM is low in size, so then the yield is a very good thing to use, not for the CPU. If you have a low CPU, then also the computation it is going to do. It can help in, just like, all the computation you do not have to perform at one time. Okay, one by one the executions can be done. In that manner, yeah, it can be done, but it actually it is connected with the RAM. If your RAM is low, so then yield is a lifesaver for you. Okay, because it is not going to store all the values in memory at once. One by one it is going to generate the values on the fly, so it will be helpful for you. Okay, and when your RAM is low in size and you are using yell, so it will avoid memory crashes. Okay, and obvious reason is there because it's never going to be load the entire data set at once. So that is the thing. Okay, so got it, sir. Yeah, okay, very good. And that was a very nice question, Suvam. Okay, that was a very nice question. I appreciate you for that. Okay. Okay, guys. I hope now everyone must have little bit knowledge about the generators. Okay, I'm not saying that much, but if little bit knowledge means you have gained about the generators, so what you can do, let's now go to the quiz session of the. Now the quiz session will be of Python generators. Okay, and let's see few of the questions. Okay, and let's you guys should try to give the answer because now you guys know about Python generators little bit. Okay, so then also it is clear. Okay, Subham is saying thank you so much, sir, for the detailed example and clarification. It's okay, bro. I am there for that only. Okay, I come live to just let you guys know about Python. So, okay, let's go to the quiz session. Okay, so I'll start again from the question number one. Okay, because I don't know what was the count of the last quiz. So, with one, we'll start. I'll keep the questions very basics in the starting. So, those who know little bit about generator, they can also give the answer. Okay, now guys, your first question for the quiz session of Python generator is: can a generator in Python be created using a function with the yield keyword? Yes or no? Now it is the very simplest question. We have seen the example of it also. So I hope that everyone should reply. Okay, I can see three yes in the chats. Okay, Subham, Saurav, and Bhaskar. Welcome, Bhaskar. So they're saying yes. Mindu Gang is also saying yes. Okay, yeah. So I'll go with yes. Okay. So yes is the correct answer for this question. Okay. Yes, we can create a generator using a function with the yield keyword. So, okay, very good. Okay, guys, your next question is question number two. Does a generator return all values at once, like a list? Yes or no? Okay, I can see three no's in the chat. So, Subham, Bhaskar, Saurabh, Gamer, they are saying no. Okay. Uh, Bhaskar is asking, can we use the Python generator as a load balancer? Load balancer, can you explain the load balancer, please? So that I can give you a specific answer for that. Because see, first of all, what's the load balancer? There are different types. In real systems, it can be servers, microservices, or distributed apps, maybe. So if you'll elaborate the load balancer for me, so I can give you a specific answer for that. Okay. Okay, let's go ahead with the question. People are saying no, that does the generator return all values at once like a list? So yeah, those who are saying no, it is correct. Very good. That it generates value one at a time. So no. Okay, guys, the next question is this question number three. Do generators support lazy evaluation? Values produced one at a time. Yes or no? Okay, Subham is saying to Bhaskar that load balancer is a different thing. Can you provide example if you have anything? Yeah, that is what I'm also asking. Uh, yes, Subham, you are correct. That is also what I want to. I was also asking to him that can you give a little bit more detail about the load balancer thing so that it will be more easy for me, no, to understand what you are trying to say. Then I can say that I know or not know, and if no, then how much I know I can tell you. Okay, okay. No, Bhaskar, now I understood. So, okay, people are, wait, let me just ask you the next question, then I'll give you the answer of your question. So, Subham is saying yes. Bhairavu Al Hassan is saying yes. Okay. So, do generator support lazy evaluation? Yes. So, yes is the correct answer of the question number three. So, yeah. Okay. Let me just give you guys one more question, then we'll discuss more detail about the question of Bhaskar. Okay. Question number four. Uh, okay, this question is very tricky. So first read the question, understand the question, and then reply it. Okay. So those who have said yes for the question number three, that is correct. Now the next question is question number four. Once a generator is exhausted, can it be reused again? Yes or no? Okay. Now Bhaskar has said about the load balancer that it is on the servers. Okay, I got your point. Got your point, brother. See, uh, generators not directly, okay, it will not directly can help in load balancing. If you talk, if you're saying to ace the server load, no, not directly, because at the server level or at the network level, what happens, it's not the generator's job. Okay, that's the job of some server providers. Okay, but yes, generators can do what? Generators can help you inside your application. Okay, generators can help you inside your application for your task and for your data balancing. For balancing your data, you can use the generator. Okay. And if little bit it will help you also, then it will help you in then there will be some scenarios, Bhaskar, then there will be some scenarios that how generator can help at that level. Okay. See, uh, when you have to stream your data lazily, okay, so then what you can do, then you can use the generator. So generator will do what, it will not, it will not overload your memory. Okay, so it will do what, it will distribute all the tasks sequentially. So for that, it can, you can use round robin technique or fair scheduling, whatever scheduling technique you want, you can just execute it. Okay, then what can happen, it will break down the large workloads. So instead of loading everything at once, what you can do, you can just yield one chunk at a time. Okay, so you will give that much data, only that much you want. Okay, so in that in that process you can use it. But for uh, I think the clear answer will be no. Okay, you can balance your data, you can balance your task, but not at that level. Okay, at network level, at server level, you cannot do it using generators. Okay, I hope you have got the answer. Okay, now, okay, Subham is saying for question number four, Subham is saying no, it will raise an error, and Bhairav is saying no. Okay, so yes, no is the correct answer, guys. So those who have said yes, okay, you guys are correct. and that we have seen also that once it is once we have used each yield, so it is not going to be rollback. Okay, so it is going to give you what was that, stop iteration, I think. Yes. Okay, so be ready for the next question. Okay, now this question I have not shown you guys till now, but let's see if anyone has already played with or have created programs on generators so they can give the answer. The question is question number 5. Can you convert a generator into a list using the list constructor? Yes or no? Mm, okay. Bharu is saying yes. Saurav Gamer is saying for question number 5 it is yes. Okay. Anyone? Okay. So no one. So yeah, I'll go with yes. So those who have said yes, it is correct. Okay. So yeah, yes is the correct answer. I think I have only asked a little bit upper level question. I think actually it was not an intermediate level question. It was a normal question only, but I've not shown you guys till now that how to convert it. So because of that, it may be you guys have feel some difficulties to give the answer of this question. It's okay. Now I'll ask what I have. Uh, okay, yeah, this thing I have told you guys. Okay, so yes, okay. Now I think this questions deserves answers. So guys, question number 6: Are generators memory efficient compared to lists? Yes or no? Okay, remember I have what I'm saying, memory efficient in compared to list. So yes or no, guys? Okay, Bhaskar is saying for six it's yes. Vairu is saying for six it's yes. Saurav Gamer is saying six for six it's yes because it is one value at a time. So okay, yeah. So we'll go with yes, okay. So yes is the correct answer. Yes, it is efficient in comparison to list. Okay, as you guys know, it does not stores all elements at once. One by one, it does the evaluation. So because of that thing, yes, it is memory efficient. So very good, very nice, everyone. Now the next question is. Now this question is very easy. Okay, and it is based on one more question. Now, question number 7, guys. Will a generator automatically raise a stop iteration when finished? Yes or no? Okay. Bhaskar is saying for 7 it is yes. Saurav Gamer is saying for 7 it is yes. Okay, Bhairu is saying for 7 it is no. Okay, good. That's interesting. Okay, so guys, let me tell you the answer now, okay? Because I think there is yes, no in the chat. So the correct answer is yes. Okay. Now those who have said no, for you, this problem is there. You can see this problem. Okay. Now this is step 3. When I again execute it, now you can see because I have used 3 else here. Okay, and I have called already 3 times. Now this was the 4th time I was calling that function. And when I call this function the 4th time, it just raises a stop iteration error. Okay. Stop iteration exception, not error, exception. Okay. So yeah. So now I hope for Baru it is clear. Okay. Now let's move to the next question. That is question number 8. That is, can you use next function to get the next value from a generator? Yes or no? Now this is very easy. So, okay, Varu is saying yes, sir. Okay, that's good. Okay, now guys, give me the answer of this question number 8. That is, can you use next function to get the next value from a generator? Yes or no? Okay, Varu is saying for 8 it is yes. Bhaskar is also saying yes, and Saurav Gamer is also saying yes. Okay, that's good. So those who have said yes, it is correct. We have seen this also, that whenever you will use next, it is going to generate the next value from the generator. Okay, so very good. Okay, now guys, there is one question now, based on your understanding. Now what I have uh, taught you in today's live session, that is okay, based on that, and plus in addition, based on your understanding, give me the answer of this question. Can generator be used for infinite sequences? Yes or no? So question number 9, can generators be used for infinite sequences? Yes or no? uh okay, Saurav Gamer is saying for 9 it is yes. Maybe we can use as many as yelled. Okay, okay, that is your understanding. That's very good. You have think something. Okay, so Saurav Gamer is saying for 9 it is yes. Okay, Veru is also saying for 9 it is yes. Okay, anyone? Anyone who knows it? Bhaskar is saying no. Okay, okay, so let me tell you the answer. Okay, so okay, there is no more replies. So I'll tell you the answer. The answer is yes. Okay, guys. So those who have said yes, it is correct. Okay. Now those who have said no, for them, let me explain you. Uh, this is a very simple phenomenon. I mean, simple. Okay, you guys will understand very quickly. See, suppose you have a infinite sequence in a list. Okay. Suppose you are trying to store an infinite sequence in a list. An infinite sequence, so mark the word infinite sequence. So what will happen? If it is a list, so all the items, all the means whole list will be stored at once. So what will happen to the RAM will crash. Okay. But when you are using generator, so generator does what? Generator will work well for the infinite sequences as it does lazy evaluation. Okay. So generator will produce one value at a time only when asked, when the next function will be called, not all at once. Okay. This is the first thing. Second, no memory overloaded. Why? Because it does not store the entire sequence at once. Okay. It will only store the current state. Okay. And then the pause and resuming. After each yield, the generator remembers where it left off. So what will happen? You will just keep generating as long as you need it. Okay. So your RAM will not crash. So it is a very good thing to work with infinite sequence using generators. Okay. So that your RAM, the memory will be freed. Okay. Will be free. So you can perform other work also, means it will not be overloaded. That is the main thing. Okay. So the answer is yes for this. And that's very nice. Everyone should participate and give answer based on your understanding, guys. It's not that if i'm if I'm saying anything, it will be correct only. Okay. It can be incorrect. So it's your job that you should come up with a good explanation, good question, so that it will be good for me also to just elaborate my knowledge. Okay. And just increase my knowledge. So yeah. Okay. Let's move to the next question. Okay, there is a very basic and simple question which I have included in the definition of generator only. Okay. It is that, is a generator an iterator in Python? Yes or no? Yeah, for that we use the yield, no? Whenever we use generator, we use yield. So yield will do what? Suppose a particular piece of code has been worked and then we are yielding something, means we are returning, means yielding some value. Okay. So what will happen? It will basically pause there. The execution will be paused there, and it will remember that where last it was means worked. So it will remember only the last value, what is that return, and the place where it has stopped. Okay. So whenever next you will call, so it will start from the second, or means from the third line. Okay. Means from the next line. So for question number 10, everyone is saying yes. Okay. So it is yes. Okay, Saurabh Gamer is also saying yes. Okay, yes. Okay, Bhaskar, is it clear? See, Bhaskar, see, guys, yeah, it just remembers the current state where it has stopped. Okay, okay, you have got it. Remember one more thing. Whenever the yield is there, so yield does what? It just basically it just executes the line and then it stops there. It takes a pause. So it remembers the current state. Okay. And whenever the next time we'll call the next, it will start execution from the next line. Okay. So that is the thing. It remembers the current state where it paused last and the current value which being yielded. Okay. So yeah. Okay. So for question number 10, everyone is saying yes. And yes is the correct answer. It is an iterator only. So yes. So those who have said yes, it is correct. Okay, let's see who can give the correct answer of this question. Okay, now guys, your next question is question number 11. That is, can a generator yield values of different data types in the same function? Yes or no? Okay, Saurav Gamer is saying for question number 11 it is yes. Okay, Veru is saying for 11 it is yes. Okay, so 11. Um, so those who have said yes, it is correct. Okay, uh, in a generator function, what you can do, the yield keyword uh, can yield different values of different data types. Okay, yes, that is possible. It's not necessary that it will yield 1, 2, and 3 only. It can yield anything. It can yield a string also. So yes, it can yield different data types also. So yeah. Okay, guys, your next question is uh, let me first put the answer of this question. That is yes. Okay, guys, your next question is question number 12. That is, does the yield keyword pause the function execution and save its state? Yes or no? Okay, Subham is saying yes. Veru is saying yes. Saurav Gamer is also saying yes. Uh, yeah. So I'll go with yes. Yes is the correct answer. Very good, guys. Okay, guys, your next question is now this question is also based on your understanding because till now I have not shown some examples like this. Okay, but I have told you in the explanation part about this. So those who have listened it carefully, they can reply it. So question number 13 is it true that generators improve performance for large data sets? Yes or no? Okay, Subham is saying yes. Veru is saying yes. Saurav Gamer is saying for question number 13 it is yes. Okay. Okay. Uh, so I'll go with question number 13. Okay. In question number 13, people are saying yes. So I'll go with yes. It is correct. Okay. So yes. Now, guys, your next question is, and the last question for this quiz session, that is question number 14. Can a generator raise exceptions like a normal function? Just like a normal function raise exceptions, Can a generator also raise exceptions? Yes or no? Okay. Okay, Suam is saying yes. Okay, one more yes in the chat. Okay, so I'll go with yes. Those who are saying yes, it is correct. Okay. So yes is the correct answer for this question. Now, guys, that's all for the quiz session. Now we'll start with the problem solving. Okay. So we'll see multiple problems. Okay. Multiple basics problems. Then we'll see some intermediate level problems also. So yeah, let's start it. Okay. So guys, first problem for today is what we have to do. We have to write a generator that will yield numbers from 1 to 5. Okay. So what we have to do, uh, first of all, let me write the problem. What we have to do, we have to write a generator that will yield numbers from 1 to 5. Okay. Numbers from 1 to 5. Okay, so let's create a function called as number generators. So num underscore gen, and we have to do what? We have to uh, yield numbers from 1 to 5. So what we can do? Okay, there are two, three approaches. One approach is very simple. We can write yield 1, yield 2, yield 3, yield 4. Okay, like that we can go till yield 5. Or what you can do? We can go with the advanced approach using the branching technique, that is for loop for I in range starting from 1 going till 6. Okay, and what you have to do, you have to yield I. Okay, now it will, this yield will do what? Because we are using this yield inside loop, so it will yield from 1 2 3 4 and 5, and we have taken till 6, so it will be executed till 5. Then for now, what we can do, again we can use a loop to call it, or you can use 4 5 print next. Okay, you can use that also, or you can use a loop also. So how you will use the loop? You'll use the loop like this on the function itself. So for n in num underscore gen colon, and you have to directly print the n. So it will give you the values one by one. Loop does what? Loop gives you the values one by one. So first time 1, in the second iteration 2, third iteration 3, fourth iteration 4, and in the fifth iteration we'll get 5, the last value. Okay, so this is also one way. Using loop you can call the function. Okay, you can call all the values instead of using print next gen each time. So that this is also one approach which you can follow. So now these questions are very basics and very easy. Everyone should understand it. Okay, and I have told you the explanation also, so that's also okay. You can use that thing also. Now, next problem. Let's go to the next problem. That is what we have to do. We want to create a generator that will do what? That will yield even numbers up to 10. Okay, even numbers up to 10. So create a generator that yields even numbers to 10. Okay, now let's create a function for that. Even gen Again, I'll just use the same thing, okay, guys. What is the same thing? Starting from 1, oh no, not from 1, from 0, because we are talking about even values, okay? So even values from 0 till 11, so it will go till 10, and I'll just add the step as 2, okay? And then I'll yield 1. Oh, sorry, I'll yield I. And again, what you can do, you can call it using a for loop, or I'll show you one more way in which you can just call this, that is using the list constructor. Inside the list constructor, call the function. So even gen, like this. So this will also do what? Whatever the generator object that will be created when you will call the function, that object will be converted into a list. Okay. So it will give you, and then it will be converted into elements 0, 2, 4, 6, 8, 10. Okay. Like this. If you have worked with higher order functions, if you guys remember map, filter, reduce, because those are the very basic examples of when you use the list constructor most of the time. Okay, because when you use map also, map higher order function in Python, so at that time also it just generates a map object. To convert it into a list, we use the list constructor, okay, to make it visible or to get your output. So this is one more way you can convert it into a list, and then you can see your valuable output. Now in same way, there is one more question, that is write a generator to yield squares of numbers from 1 to 5. Now guys, I hope everyone will know. Now I'm going to use the same approach now, okay? How? Only the function name will be different. Def square gen, and then for I in, again, range starting from 1 going 6, and I'll, okay, not print, we have to use yield I, not I, yield I into I, okay? And then just simply print list and square gen 1496925, okay? Okay, let's check the next problem. Now, those who have, I'm giving you guys one assignment. Those who have guys are with systems, what you can do, you can write the same program for printing the cubes of numbers from 1 to 5. And I think that is very easy. You guys can just do it very quickly, okay? So you have to just do what? You have to just, not now, whenever you are free, in your own time, just you have to print the cube using the generators, okay? Okay, let's see one more program, that is, now guys, if you'll notice in all of the programs here, what we have done, instead of return, earlier when it was a normal function, we were using return. Now we are using what? We are using yield. And the output also seems somehow similar, but actually the working process is not similar. Okay, it's generating the value one at a time. In return, all the values are generated at once. So there is a difference, but that difference is not visible to us. Okay, that is the thing. uh, there is one more program that will show you the size of a normal function and a generator function. Okay, let's see that. So get the size of a normal function and a generator function. Let's see that. So with this, why I'm just writing this program, because to show you guys the difference, okay, the actual difference, okay, because the output seems somehow very similar to the normal function. Okay, so most of the people will confuse and say that what is the difference, what is the difference. So now we'll see the difference. Okay, so for that we have to import one module, which is the system module, because from this module we are going to use a method called as get size of. Okay, before that I'll just create uh, two functions which will take one input, that is n, and the normal function is going to return I for I in range n. Okay, n. Then I'll create one generator function. So make gen, this will also take an input of n. So for I in range n, what we'll do, we'll yield I. Okay, and then we'll do what, we'll use the print function, and in the print uh, let's say function object size. Okay, we'll check first the function object size. So for that we'll use system sys dot get size of, yeah, this is the function name, and we'll put the function name over here. Okay, because this is the object name also of that function. And then again I'll just copy it and I'll paste it over here. Now first we'll check the object size of both the function and the generator, and then we'll check the size of the returned values also. Okay, so let me make gen, and let me add generator over here. The generator function object size, and I'll do what, now I'll call it, so I'll create a list object. Okay, and I'll call the make list function, and I'll give a very big value, 10,000. Let's give one more, and let's create the gen object, and let's call the make gen with the same amount of value. Okay, and then now let's check the size of this list object, and let's check the size of this gen object. Okay, so list object size and generator object size. Okay, now let's run the code. Okay, now guys, you can see the clear difference over here. Okay, first of all, when we have created both the generator and the function, so the function object size is also 152 and the generator function object size is also 152. But now when we have checked the size of the returned values, okay, means the size of the list object and the generator object after execution, you can see a clear huge difference. Okay, list object size, list object size is 1,100 8 lakhs 90 984, whereas the generator object size is 208, only 208, because it generates the values on the fly, on the go, one by one. Okay, not all the things at once. So on the memory it puts less load in comparison to a normal function. Okay, a function which creates a list. That is a clear difference, guys. So why it's so, because of this purpose it is memory efficient. So all these programs which we have seen, they are memory efficient, okay, in comparison to normal functions if we'll create a normal function for that same purpose. Okay, So that is the thing. I hope the difference is clear to you guys. Now guys, I think let's keep this much only for today because uh, we'll continue this in the next live session, or there is no need. Now, all the problems which we have solved with normal functions that we can easily do it or convert it into an yield. And now you know the size calculation also, that how you will get the size of each function. So you can check using importing system and using the get size of, okay. So you can check the real time size also, okay. It always on you. And if you want some questions that I should mention some question to you guys, so suppose write a generator to yield uh, alternating values, positive and negative numbers from 1 to 5. So these types of questions are there. Then for finding the vowels, okay, you can create a generator to yield vowels from a string, that you can create. So these types of questions, normal function questions, you can convert it into an generator function using the yield, okay. So so thanks everyone to joining the live session, okay. I hope you guys are learning, okay. You guys got to know something about the Python generators, okay. And it is always a uh great interacting with you guys, okay. You guys, I come to know that how many people are have a keen interest in learning Python, and they put efforts also. That's very good, okay. So yeah, that's all for today. Once again, thank you so much for joining the live session, okay. And yeah, and we'll see you on the weekends again, or if there will be any holiday, I'll just give you a notification. And whatever the places you have joined me or you are connected with me, I'll just notify you at that places, okay. So you guys can go and follow all the places, okay. So yeah, that's it. Thank you. We'll see you in the next live session. Till then, bye, take care.